Okay, so today we're doing lesson 2.1 all the way to 2.3. All on one page. And the topic are fractions and decimals. Okay, and it's 9:27, and this is period 7. There's two essential questions that I want you guys to see today, and it's how do we compare and order rational numbers? We've been doing that. How do we compare and order rational numbers? You can abbreviate. And then how do we add and subtract fractions? How do we compare and order rational numbers, and how do we add and subtract fractions? Okay, so by the end of this page of notes, you should recall how to do all of these things. The vocab, there was some vocab from the other day that we're going to write down. One of them was the repeating decimal thing. And we kind of learned how do we notate these with the bar notation. So we had things like 0.333, and it kept going, right? And we wrote that as 0.3 with the bar over the top. That's called bar notation. And then we had another one that was like, I don't know, 0.4545 ... So you put the bar over just the 45. And I know you did that in 6th grade too, so that's a little bit of review. You could also get one where like you have a different number out here, so maybe it's like 5, and then you have 32, 32, 32, something like that. So you write that as 0.5, and then just the 32 has the bar over it. Simple stuff. So that's repeating. There's terminating decimals as well, like the Terminator. Terminating. Terminating decimals end in 0. They never put the 0, but you have to assume it's there. So that would be like 0.25, which equals 0.25. Okay, let's put a little star under this. And let's just remind ourselves we have to be smarter than the calculator. So let's put your calculator rounds up. Most of them anyway. Example. Some of you saw this yesterday. 0.6666667. Do you remember that? So your calculator is rounding it up because it's run out of room to keep writing 6s or typing 6s. But it's not really there. So the answer to this is really just 0.6 repeating. So again, we have to be smarter than our calculators. Any questions so far? 6th grade stuff, right? Okay, and then we did this thing called write fractions as decimals. Write fractions as decimals. And we looked at some place value stuff for shortcuts. So here's an example of like the shortcut thing. If you have 7/10, what is that as a decimal? 0.7, because that's in the tenths place, right? 7/10. And what if you have 19 over 100? What is that? 0.19, right? Because there's a 1. And what if you have 105 over 1,000?
105.
Yeah. So we look here. Okay, this is the tenths, and it's over 10. This is the hundredths, and it's over 100. This is the thousandths, and it's over 1,000. So we have to know our place value. The other way to do this, especially if you don't have a real easy one like that, like 10, 100, 1,000, right? Let's say you have like 7 over 13. So you could just put that in your calculator as 7 divided by 13. Do you get it? You remember how to do that? We just did that. Okay? So 7 divided by 13, I don't know, it's about half. So when you have things like that, just put it in your calculator. So I'll write calculator next to this. Okay. Any questions on that? It's all review, right? I hope. Some of it. Most of it. Okay, one of the words that might have been new was rational number. You guys remember that from yesterday? Rational number. This is any number that can be written as a ratio or fraction. So let's write that down. Any number that can be written as a ratio. Oops, started spelling it again. Ratio or fraction. And you'll notice ratio is in the first part of rational, right? The root word. Okay. So rational. So things like decimals, fractions, percentages, those are all rational numbers. And then there's another kind of number, not as common, called irrational. So it's the opposite. The thing about irrational numbers, bless you, is they never repeat. They just go on forever. And there's one very special irrational number. Raise your hand if you know what it is. It's a number that never repeats. It is a decimal, and it goes on forever. No one's found the end. You two know? What is it? It's not 0.
One.
It's not 1. What? No? Nolan?
3.
It's a number that never repeats, and it goes on forever. No one's ever heard of this special number? They have a special day in March on March 14th. Catherine? Pi. Pi. This is pi, right? Pi. P-I.
You said hi.
3.14 ... goes on forever. And it never repeats. So put never. Repeats. Now, here's the thing. This is true. There's people, they're crazy math people, and they've locked themselves in like basements and attics for years trying to find the last digit of pi. And they're using like very sophisticated computers and they can't find it. So I kind of think they should maybe give up.
What does pi even mean?
It's just it's a number. It starts like 3.14, and then these digits keep going on forever, but there's no pattern.
Oh.
There's no like, you know how like the other ones are like 5, 4, 5, 4, 5. There's no repeating numbers. So in order anyway. Like you can have 1 through 9, but they're in some kind of random order, over and over again. That's pi. There's another irrational number, but I don't think anybody knows it. Because you don't do this until, maybe not even until like your 4th year of high school now. I don't know how Math 3 is. But it has a little I, and it stands for imaginary. Those are irrational. Okay? So, but pi is the only one that we really use in here. Okay? So, Not too tricky. Is there a question about pi? We can move on. You want to lock yourself in the basement? Yeah.
So they're locked in the basement and they're actually like.
Well, they like lock themselves in because they're trying to find it, so they don't want to be distracted.
Like, what do you mean? Like it goes on?
It just keeps going. Like if you guys later on want to Google it, it'll just keep. It's like keeps going and going and going, and then finally at the end it'll just be like dot 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 because nobody knows the end. Yes.
What would you, if you want to like look it up? What would you like to type in?
Google the digits of pi. Are you guys really obsessed with this, huh?
Yeah.
Okay, we gotta move on from pi, but we'll come back to it. Only because we're recording, we don't want an hour-long notes. Okay, so the last thing, this is the last thing. And this is kind of like the homework stuff. And I'm just reminding, add and subtract fractions. And today we're only gonna do like denominators. Next class we'll do unlike. So if you add and subtract fractions, here's two examples. Number one, really simple. Here we go. Let's do 4/9 plus 2/9.
Oh, that's easy.
Yeah, that's easy, right? This is what your homework is. So what's 4/9 plus 2/9, class?
6/9.
Wow. And then you have to simplify. So you divide top and bottom.
1/3.
Divide top and bottom by 3. And that's 2/3. A lot of people missed that on the quiz. They weren't sure how to divide.
Wait, 3/3 is.
Divide by 3. Okay? To simplify. So this is your final answer. Now, if on a quiz you left it as 6/9, I would give it to you because I've told you in calculus you leave it as 6/9. But since we're not in calculus yet, right? I'll still let you leave it because I've told you that. But if you simplify it, it's fine too. If it's a multiple choice test, it will be simplified. Okay? All right, number 2. This is the difference between 6th and 7th grade right here. Negative 3/5 plus a negative 1/5. The negative sign is the only difference there between 6th and 7th grade. Who knows the answer? Say it out loud.
4/5.
Negative 4/5. Okay, that is what your homework is tonight.
Yay.
Yeah,
Just adding?
Easy.
yeah, and adding, and I call it subtracting as well because some people might just say minus 1/5, you know.
Oh. I like that.
Okay?